Alright, this is video 8.5C in elementary algebra, still doing roots and radical expressions. This is example number 10B, and we're simplifying these is what we're doing. So let's go ahead and get started. Let's split these up. If that is a good idea, that's what you usually do first, is split them up so that you can simplify what's on top and then simplify what's on bottom. Always remember what your index is. You need to make sure that you put the right index on there. Okay, so now let's do some simplifying. Is there anything I can do up here on the top? Oops, come on. See if I can get this to work for me. Any way I can reduce what's on the top? Yes, there is. Because this number is bigger than this, I know that I can do some things. So I've got equals the cubed root. Okay, so I look and say, there's no exponent on the 3, so it can't come out. There is an exponent on here. 3 goes into 4 one time with 1 left over. So that can be reduced to that. The bottom, since all of the exponents are less than 3 there, we can't do anything to that. So we end up with that. Alright, so now we're simplified, but we still have a radical in the denominator position. So we need to get rid of that radical. So let's go ahead and rewrite this right here. And remember, in order to solve this, we need to multiply the top and bottom by something that's going to give me just 4y squared z index cubed. So I need that. So I need to multiply it by the exact same thing, but I need to put an exponent up here, right here, so that when I multiply this times this, I get a 3 up here. And in this case, it's going to be a 2. Because when you multiply numbers or terms with exponents, you add the exponent. So I've got a 1 up there. So this 1 plus this 2 will give me this 3 that I want there. So if I do that on the bottom, I have to also do it on the top. Alright, so on the bottom, I know what my answer is going to be. It's going to be right here. And on the top, whoo-wee, I get quite a load. I get x cubed root of 3x times the cubed root of, I'm just rewriting everything, I get that. So this is where I'm at this point. So let's go ahead and move some stuff around so that we can write. Golly, it's hard to move everything. Alright. So what did we have on the bottom? We had the cubed root of 4y squared z cubed, right? Alright, so my denominator turns into just 4y squared z because the radicals disappeared, because this 3 and this 3 take them all away. Now multiplying this puppy is going to be the strangler. Alright, so we're going to write that the way it is. Let's just do one bit at a time. So what does this squared mean? It means I square everything in here. So times the cubed root, 4 squared is 16, y squared squared is y to the 4th, and z squared. Okay, now let's multiply that. So our x we don't do anything with. There's nothing to multiply it by, but everything inside, I can multiply the 3x times that. 3 times 16 is 48, and then x y to the 4th z squared over 4y squared z. All right, now to simplify this even more, I need to see if this 48 can break down. Okay, so two numbers multiplied together give me 48 that I can also take the cubed root of. So let's move everything up. Come on, trying to get everything out of the way first. Okay, so I have some room. All right, so let's see, 24 and 2, there's no cubed root of 2, no cubed root of 24. 8 and 6. So I could change this to 8 times 6, right? That's 48. And I can take the cubed root of 8, which is 2. And I'm just writing everything down again. All right, so the cubed root of 8 is 2, so I can bring that outside with the x. And there's my index. 6. I don't have any exponent there, so that can't come out. 3 goes into 4 once, with 1 left over. And since that's less than our index, it stays in there as well. Gosh, this gets to be a big one, doesn't it? All right, now I can see if I can cancel. I can cancel this 2. 2 over 4 is the same as 1/2, right? So I have xy cubed root of 6xyz squared over 2y squared z. Oops, and I have a y here that I can cancel with one of the y's here. And that ends up being my answer. X cubed root of 6xyz squared all over 2yz. Whew, baby. There's a lot of stuff going on there. Okay, let's go to the problem set. Okay, this is number 46. And let's go ahead and see if we can do this. All right, so first step, we're going to split up our radicals. Do just the radical on the top. See if we can simplify it first. Whoops. And then the radical on the bottom. All right, so can we do anything with 30? Two numbers multiplied give me 30, where I can take the cubed root of one of those. I have 6 and 5. Can't take the cubed root of those. 10 and 3. 15 and 2. Okay, so I'm not having much luck there. So it could very well be that this is as reduced as the 30 is as reduced as we can go. So let's look back at the very beginning here. And this happens a lot, where you write things out and then it's like, something's just not working. Go back and see if maybe you're missing something. And I am. 30 over 2 is 15. So I can write this as 30 over 2 is 15, so these go away, and then you have x to the 5th, y to the 6th. I have no fractions. Life is good. 15, I can't reduce that anymore, so that 15 is gonna stay in there. 3 goes into 5 one time with 2 left over. 3 goes into 6 twice with none left over. And that ends up being my answer. That's as much as I can do. So see what happened there? I looked at this and automatically said split these up, and then I was stuck. I couldn't go anywhere. So I went back and looked at this and thought, is there anything I can do before I split my radicals up? Yes, 30 over 2 is 15. Got rid of my fractions completely. Life was so much easier. So just some things to think about as you're doing these. Okay, so let's do one more. One of the things I want you to know is example 10. Remember how hard that was? There aren't any that are that difficult in this lesson. In fact, let's jump down to number 48 and do that one just to show you. We have 5x to the 7th over 3y squared, and it is under a cubed. All right, so if I split these up, can I take a cubed root, okay, or can I go 5 over 3 before I split them up and solve this? No, I can't, so I'm going to have to split them up. I can't reduce it anymore. So let's go ahead and see if I can write smaller. Okay, so again, I'm looking to get a 3y squared radical cubed with a 3 up here. That's ideally what I'm looking for. So I'm trying to go from here to here so that I can take the radical sign off. So let's multiply top and bottom. In this case, 3y squared squared. And I'm going to do the same thing up here. Alright, and that will give me that there. So let's go ahead and do the actual multiplication. My bottom is easy enough, 3y squared. Okay, my top, multiply that times that. But first of all, I have to change that. So let's just go ahead and write this as 5x to the 7th again, times the cubed root of 3 squared is 9y squared. Oh, and this is this y squared here is squared, so this is actually going to be y to the 4th. Do you see how that happened? Let me get my pointer here. This squared, see, we took the 3 and squared it and got 9. Take the y squared and square it and get y to the 4th. Alright, so now we're going to keep going on that top. Our bottom is already simplified. So let's go ahead and multiply that. Cubed root 5 times 9 is 45. X to the 7th, y to the 4th over. So notice when you rationalize the denominator, it's the top that ends up being the hassle. Alright, so 45. Can that be reduced at all? No, it cannot, because 9 times 5 is 45. 15 times 3, that's about it. And I can't take the cubed root of any of those. So really that 45 is as low as you can go. So the cubed root, whoops, let's move this over. Cubed root of 45, can't do anything else with that. 3 goes into 7 twice with 1 left over. 3 goes into 4 once with 1 left over. And then we have 3y squared, and notice I have a y here, and I have 2 down here. So I can cancel this y with one of those. And I end up with my final answer being just a cleanup of this. That right there. Okay? So not ridiculously crazy, but enough crazy that might be a little bit tough. But that's it for problem set 8.5. I don't think you're going to have too much trouble if you can do this one that we just did. I think you'll be fine.